Okay, so this is question number 10 in the first exercise in constant acceleration in the M3 book. Okay, so question number 10, they say a car is traveling along a straight road. As it passes a sign S, the driver applies the brakes. The car is modeled as a particle. At time t seconds, the car is x meters from S and its velocity v meter per second is modeled by the equation v equals 3200 over c plus kt, where c and k are constants. So what have they given you? They have given you an equation relating the velocity and time, right? So given that when time is 0, the speed of the car is 40. Okay, they've given you an initial condition at time 0. At time 0, your speed is 40 and the deceleration is 0.5. Wait, they've given you what? Deceleration is 0.5, which means what? Now we are modeling and working with acceleration. Equations that give us acceleration. If deceleration is 0.5, it means when time 0, velocity is 40, acceleration is minus 0.5. That's the meaning. Okay, time 0, velocity 40, acceleration is minus 0.5. That's the meaning of the deceleration. Find the value of C and the value of K. Okay, they're asking you to find the value of C and K. We can easily find the value of C and K. Okay, the first thing you can do here is we already have the equation relating velocity and time, right? So what can I do? Do you see that I already have a value that I can use as the input here? Because they've told us at time 0, velocity is 40. So we can input that value into this equation to find one of these constants. Or we can find some equation relating the two constants C and K. Shall we find it? So in part A, we know velocity is equal to 3200 divided by C plus KT. So let's input the value. T0, velocity is 40. Let's input. So what do we get here? Velocity is 40 equals 3200 over C plus K into 0 is 0. So what can I do here? I can now easily find the value of C. So 40 times C, I brought the C up, equals 3200, which gives me C equals 3200 divided by 40 is 80. C is 80. Okay, so now I found the C value. However, the question part A asked me to find not only C, but also they want me to find the value of K. How do I get the value of K? So the thing is, they've given us the time at time 0, velocity is 40, and also at time 0, they've given us the acceleration. So what does that mean? We can, now I have the equation relating velocity and time. So there's no other input. Now I got the C value, which means actually I can rewrite my velocity equation, right? I can rewrite my velocity equation as what? 3200 over, instead of C, what do we write now? Yeah, we can replace the C with 80 plus KT. But another thing is to get K, I can't, like they have not given me any other information regarding velocity and time. Okay, only time 0, velocity 40 is given to me. So to get the value of K, they have given us at time 0, they've given you the acceleration. So let's make use of that. How do we make use of that? I have the velocity equation. We will, what do we have to do to convert velocity to acceleration? We will differentiate the velocity equation and get the equation with acceleration, and then go for another substitution with T0 acceleration minus 0.5 to actually get the value of K. Okay, are you with me? Let's differentiate this equation now and get the acceleration. Okay, so to differentiate now, I want differentiate velocity and get the acceleration. So one way of doing this is, so these are the differentiation rules that we learned in P3, right? So you don't need to, I mean, I think we can directly go with the first rule. To go with the first rule, here the function is t, okay? You're doing this with respect to t. So you could bring the 80 plus kt to the numerator as a power of minus 1, right? You don't, if you want, you could even do it with the quotient rule, the 12th rule. But quotient rule is mainly required if you have both t functions at the numerator and denominator. So over here in the numerator, I'm simply having a constant. So I could rearrange the velocity equation as 3200 times 80 plus kt to the power minus 1. Okay, are you with me? So now I could differentiate this by using the first rule. In the first rule, the priority is, we give the priority for the power. First, we take the power forward, subtract 1 from the power, and then we go in and differentiate the function. So I get dv by dt. When I differentiate velocity with respect to time, I get dv by dt equals 3200 times. So how do we differentiate? The minus 1 comes forward. 80 plus kt to the power. You subtract 1 from the power. So 80 plus kt to the power minus 2. And then after you're done with the power, now go inside and differentiate 80 plus kt. What is the answer? Times 80 differentiation is 0. Kt differentiation. Now remember, you're differentiating with respect to t. Therefore, kt differentiation is a k. Are you with me? If it was 2d, it's 2. Likewise, kt, k is a constant. T is the variable. So we differentiate with respect to t. Kt differentiation is k. So now I got the dv by dt. So I introduced you in the previous section. dv by dt is what? Acceleration is dv by dt. Do you remember? Acceleration is dv by dt. Therefore, I replace dv by dt with a. Acceleration equals minus 3200 into k. Shall I bring 80 plus kt down? 80 plus kt square. 3000 minus 3200 k over 80 plus kt square. Do you agree with me? So this is the acceleration. And you know, when you're accelerating, do we put any pluses or any plus constant? No, that only works when you're doing integration. Okay. So now I have the equation relating acceleration and time. So all I have to do here is now let's replace when time is 0, acceleration is minus 0.5. Okay, let's replace when time is 0. When time 0, acceleration is minus 0.5. Let's replace minus 0.5 equals minus 3200 k over 80 plus k into 0 is 0, right? Square. Minus 0.5 equals minus 3200 over what is 80 square? 80 square is 6400, 3200 k here, right? So the minus mark, we can remove it. And k equals 0.5 into 6400 over 3200. Do you agree with me? Okay, so what is k? K equals to 1. Is this clear? So this is the answer. So they wanted us in part A to find the value of C and K. So we got C by using the original equation, and I got K by differentiating the given equation, getting the equation for acceleration, and then inputting the given, they gave us these boundaries at the very beginning. At time 0, acceleration is minus 0.5. So we used that and we got the K value. Is this clear? Okay, so we'll move on to part B now. Okay, so in part B, they ask you find x in terms of t. What do you mean by x in terms of t? X in terms of t means you have to get the displacement in terms of time. So now currently I have velocity with respect to time. So from velocity, how do we go for displacement? Velocity displacement, we must integrate. Okay. So I think now we have the complete velocity equation, because you know the velocity equation was previously given to us with some constant, with unknown constant. So we found the complete velocity equation. Let's write it down. Velocity equals 3200 over what was C? C value was 80 plus what was K? K was 1, right? So 1t, basically 80 plus t. So velocity equals 3200 over 80 plus t. This is what we had. So now I have to get x in terms of t, meaning I have to get the displacement. So how we are going from velocity to displacement, I did tell you in the previous section though, in velocity is what? Dx by dt, right? Do you remember this? Velocity is dx by dt. So we could do it a little bit better by using velocity as dx by dt. Are you with me? Velocity equals to 3200 over 80 plus t. And what did I do in the previous section? So in the previous questions, in the earlier questions, like instead of directly integrating velocity, I did have the habit of writing velocity as dx by dt, and I took the dt to the other side. I took this dt to the other side. Are you with me? So what does that do? Dx remains here. This is 3200 over 80 plus t. And dt comes here. So what does this do? So when I put the integral sign, what does this tell us? This the left side integrates with respect to x. The right side integrates with respect to t. Are you with me? The left side integrates with respect to x. The right side integrates with respect to t. So over here, just integrating x means you should know it's, when there's nothing over here, it means we are integrating 1 with respect to x. So when you integrate 1 with respect to x, what do we get? X. Okay, so now you have to go for the integration rules in P3. 3200 over 80 plus t. Okay, so 3200 is simply a constant. We can take a constant out of the integral sign, right? So 1 over 80 plus t with respect to t. So you need to check the integration rules to see how you integrate this. Okay, how do we integrate this? Okay, so when you integrate 1 over 80 plus t, so I have got the general rules of integration here. So we integrate with the ln rule, third rule, right? So I have written the P3 rules of integration here that we generally use. So when we integrate x equals 3200, 1 over 80 plus t. So it's going to be ln 80 plus t, right? So actually when you have here instead of x, we have the variable is t. So ax, in the sense I don't have any coefficient with the t, because if I had some coefficient with t, we would have to divide. But do you have any coefficient with t? No, right? So then we don't need to divide. So therefore 3200 ln 80 plus t, and don't forget, but after the integration is done, you must put plus c. Okay, so now the challenge is to find this plus c. Okay, so let's try to go for the integration. Okay, so the integration plus c. How do we find the plus c? To find plus c, we need to have an idea about, we need to input some kind of a boundary condition. So they should give us some clue. Have they given us some clue? At time 0, the speed of the car is given and the deceleration is given. Okay, I don't see anything about the displacement given here. So let's just read from the beginning. What do they say? The car is traveling along a straight road. As it passes a sign S, the driver applies the brakes. Okay, so I have a feeling this sign S is where we measure our displacement from. Look, the car is modeled as a particle. At time t seconds, the car is x meters from S, which means what? The car is x meters from S means we measure the the displacement from S. We measure the displacement from S. Okay. So I think, yeah, as it passes a sign S, in the sense in this question, the question says as it passes a sign S. So obviously, the question starts. I mean, it's not directly given to you, so you'll have to read and understand. So at time 0, because we are going to measure the time as it passes the sign S, the driver applies the brake, because we start measuring the time as the driver applies the brakes, right? So driver applies the brakes start as it passes the sign S, which means the timer starts at the sign S. And which means what? If the timer starts at sign S, at time 0, your displacement is going to be 0, because you are at the point S when you are starting this question. So then you need to realize at t0, x is 0. So that is something you need to read and figure out. Okay, I hope it makes sense to you, because as it passes a sign S, the driver applies the brakes. So from that point, you start the timer, they start measuring the time, and at time 0, at that particular time, the displacement is 0, because you are directly at the point. So then we can use that and find the value of our c. They want us to find x in terms of t. Okay, let's do that. So x equals 3200. Okay, actually x is 0. 0 equals 3200 ln 80 plus 0 plus c. So I get c equals minus 3200 ln 80, right? Guys, do you agree with me? This is my c value. So let's input the c value back into the main equation and get x, because that's what we do. You get the integration constant, input it back into the main equation, and I get x equals 3200 ln 80 plus t. Plus c in the sense it's minus 3200 ln 80. Are you all with me? And then for this, we could use a little bit of P2 logarithms, P2, P3 logarithms. So how does logarithms work? You can see 3200 is a common constant which I can take out, and I have ln 80 plus t minus ln 80. So what does this remind you? Do you remember the rule log A minus log B? What does it remind you? Log A minus log B is inside a single logarithm A divided by B, right? So this is like me, us going to the simplest form, trying to simplify as much as possible. So therefore, x equals 3200 into ln 80 plus t over 80. So this is the equation in simplest form where you see the relationship of x with respect to t. Okay.